Hello students, welcome again to this session. Today is still on X-rays and we'll be looking at properties of X-rays. In the other session, we got to see how X-rays are produced in an X-ray tube and also the various parts of an X-ray tube and their functions. So welcome to this session. By the end of it, you should be in a position to explain all the properties of these waves that we call X-rays. And straight to the first property of X-rays, and this is on whether these X-rays have any charge or they have a charge. If we take an X-ray beam and we pass it in an electric field, that is where we have the positive. Remember, an electric field will always move from the positive terminal to the negative, that is from positive charge to the negative charge. If we are to pass an X-ray beam in an electric field, then we find that they do pass without being deflected by this electric field. On the same note, if we have an X-ray beam and we pass it in a magnetic field, then again we find that the X-ray beam will pass straight without any deflection. And therefore we find that X-rays are not deflected by either magnetic or electric field. And that means that X-rays are not charged. X-rays are not charged. They don't have any charge. And that is the simple reason why they are neither deflected by an electric field or a magnetic field. The second property of X-rays is that they are able to penetrate matter. They have energy, like we saw in electromagnetic spectrum. Remember, X-rays are part of electromagnetic spectrum. And all the waves of electromagnetic spectrum, they do carry energy. And we calculate this energy in Planck's constant times the frequency of these waves. So this energy, when the X-rays fall on any material, they are able to penetrate the material. And the magnitude of penetration depends on the density of the material. Materials that are very light in density, then the X-rays are able to penetrate easily. And they are stopped by materials which have a very high density. That is, they have very low penetration in materials of very high density. That is, a material like lead. And this explains why in the X-ray tube, we used the lead metal to shield the evacuated glass, because lead is has a very high density, and therefore it is able to absorb the X-ray energy, and they are not able to penetrate through a very thick lead metal. Property number 3 is that these X-rays affect photographic emulsions. Remember when we looked at the pinhole camera and we found that we can put a photographic film and then light will be able to affect the photographic film and imprint the image of the object that is shining the light on it. The same thing can happen. If X-rays fall on a photographic film, then they cause emulsions. And that is the concept that is used in X-ray photography, as we shall be looking at in the uses of X-rays. The other property of X-rays is that they cause air ionization. What do you mean by this? If X-rays pass through air, in this case we have these are air atoms, then the X-rays, remember we are saying they do carry energy, and therefore when they pass through air, they are able to knock off electrons out of the air atoms, and therefore that air atom will be left ionized. It will no longer be the atom, but an ion of air, which will be positively charged after the electron has been knocked off. So X-rays do knock off electrons from air atoms to make them ions, what we call air ionization. And this helps in increasing the conductivity of gases. Remember, when air ionization occurs, we are creating charges here, the positive charge and the negative charges as well from the electrons. And remember, conduction is all about presence of ions or charges that do flow and therefore helping in conductivity. Property number 5, they cause photoelectric emission. In our last topic, where we were looking at cathode rays, we found that when we heat a metal, we can eject electrons from a metal surface using the heat energy. Again, these X-rays do carry energy, what we call the radiation energy. If we happen to have a radiation shown on a metal surface, then the energy can also be absorbed by the electrons of the metal and be ejected from the metal surface. This means that these electrons are now using the energy from a radiation. Now in this case, we don't talk of thermionic emission, we talk of photoelectric emission. Therefore, X-rays can cause metal surfaces to eject electrons through the process that we call photoelectric emission. Property number 6 is that when X-rays fall on fluorescent materials, and we said some of the fluorescent materials we have is phosphor, and phosphor, we say this is zinc sulfide, then they'll always make fluorescent materials to glow or to fluoresce. Our next property is, so the 7th property of X-rays is that X-rays are part of the electromagnetic waves, and we found that they have a wavelength that is shorter than UV. Remember, X-rays, when you look at the electromagnetic waves, we have the radio waves, the microwaves, the infrared, visible light, UV, X-rays, and the gamma rays. Therefore, X-rays, this is increasing frequency, and therefore this is also reducing wavelength. The wavelength is reducing, and here the frequency is increasing. Therefore, X-rays, as part of the electromagnetic waves, you find them between the ultraviolet waves and also the gamma waves. That is ultraviolet, and then we have the X-rays, and then finally we have the gamma. So X-rays is between ultraviolet and also the gamma waves. And in this case, we'll find that X-rays can be plane polarized and also diffracted. And this plane polarization simply means that the particles or the waves, as the waves move, then they are particles that, if they are in a material, they displace the particles along the same plane. And if these were waves that were moving, for example, in this case, this being the direction of the wave, you can see that particles are perpendicular to the direction of the wave. If we were to put a slit here or an opening that is horizontal, then these waves will all pass through this plane that is horizontal, and therefore their orientation will change to not being vertical, but now the direction of the deflection of the particles along the way will be horizontal, and this means that these waves have been plane polarized. Their orientation have been changed from this orientation of vertical to a horizontal orientation, what we call plane polarization. And they can also be diffracted. Remember, diffraction is where if we have waves and they get through an obstacle which has an opening, then the waves are able to spread behind the obstacle. That is diffraction. So X-rays, just like all the other waves, they exhibit all the properties of waves, and therefore they are waves in nature. Finally, X-rays move along a straight line. They are linearly propagated, and they do so with the speed of light, which is 3 times 10 to power 8 meters per second. Therefore, they are linearly propagated. They move along a straight line with the speed of light. Those are the properties of X-rays, the 8 of them, and I can see these are properties that are they can be easily understood. Thank you. Let's meet in our next session.